Today's lesson is a continuation on section 8.1, applying exponent properties involving products. Yesterday you did the exploration packet on this section. What happens with powers when we're multiplying powers together? There are certain tricks you learned, or three particular rules I'm going to just go over again for ways I can simplify things that have powers. In math, we're always trying to simplify things. We're trying to simplify sometimes by distributing or collecting like terms or some of the tricks we've learned in the past. Same things with problems like this that have powers involved. Sometimes there's little tricks we can use to help simplify them. Now, you've learned in the past that powers just mean I'm taking a number and I'm multiplying it by itself, and sometimes in a problem, that's the best we can do. Take a look at the two examples I've got here. This first one, I've got 3 to the third plus 5 squared, and all I can do in that problem is, well, 3 to the third is 3 times 3 times 3. And I'm going to add that to 5 times 5. And I figure out those numbers, I'd add it, I'd evaluate and find some kind of answer. Same thing with this next one, 2 to the fourth times 3 squared. Again, there's no little trick I can do. In certain powers, or certain problems that have powers, like these ones, I just have to evaluate and find an answer, and there are those problems almost written out in expanded form, and then I could go from there to find the answer. But yesterday you learned there are certain problems that we can do certain tricks with. And one of those rules that we can use when simplifying problems that have powers in them, is one that looks like this. I have 3 to the third times 3 squared. Notice I'm multiplying and my base numbers are the same. And so what you learned yesterday by breaking this case apart and then finding a rule that works for this is if you are multiplying powers that have the same base, what I can really end up doing is just adding the exponents together. I keep that base and I add them. Just kind of showing you and reminding you what you found yesterday. 3 to the third, what does that really mean? 3 to the third is really just 3 times 3 times 3. And then what if I'm going to take and I'm going to multiply that, just like this problem says, multiply, and then I'm going to multiply it by another 3 times 3, which is 3 squared. Well, really, notice what I'm doing. I'm just multiplying 5 different 3's together. So really a shorthand way to write this is 3 to the 5th power. So the first rule you learned yesterday from that packet was if I have 3 to the third times 3 squared, it's really, I can just jump right to my answer, 3 to the 5th. That's what we mean when we're saying we're applying some of these power rules using products. So here are a couple examples, just like ones you did yesterday in the packet with the very first rule that you learned. We're going to learn, as we're going to find out 6 different rules here that we can apply when we're dealing with powers and we're dealing with products or dividing or things like that. Take a second right now and see if you can figure out these 3 problems before I even go through them. I'll try to go through them up here, but go ahead of me and find the answers if you can. This first one, 4 to the 6 times 4 squared. This will be the last one that I'll just kind of write out in expanded form, but just remember what it means. 4 to the 6th. It means 4 times 4 times 4, 6 different times. Then I'm going to multiply that, well, times 4 squared, which is 4 times itself 2 more times. So 4 to the 6 times 4 squared, you started to figure out yesterday, well, that just means you're multiplying 8 different 4's together. So what's really the rule? When I'm multiplying powers, again, it's exponent properties involving products, things we can do when I'm multiplying powers together. If you're multiplying powers and the numbers have the same base, I just keep that same base and I can just add these 2 exponents. That's one rule we can do. Look at the next one. I got some big numbers here, 15 to the 14th and 15 to the 26th. It's some huge number. I don't really want to find out the big number and evaluate this and find the final answer. We're just going to simplify as the directions want us to do and write our answer using an exponent. Well, since these are the same base, this is like 14 15s multiplied together, and this one is like 26 more 15s multiplied together. And if I wrote it all in expanded form like I did above, it'd be 40 15s multiplied together. So I can just write that 15 to the 40th power. Same thing with this next one, even with variables. R to the 12th times R to the 9th. Well, something to a power or to an exponent already means you're multiplying. And multiplying R times itself 12 different times, and then times itself 9 more different times. And I could write out all the R's that there would be, but really I can just also know that I'd write out 21 different R's if I lined them all up. I just add the 2 exponents together and keep that same base, so R to the 21st. So right here, now you'll have in your notes, and you found out this in the packet yesterday, but here's the name for this first rule that we learned. So you could even label this rule number 1 for the rules that we started learning yesterday in that packet, the product of powers rule. And again, and don't be fooled by the words. These are all things you know, product. When you're multiplying powers. So when I'm multiplying powers together and they have the same base, it says keep that same base and I just add the exponents. Go ahead and try the ones below, and I'm going to go through them in just a second as well. I'll give you a second to try them, see what you can get from the answers from all those using this same rule, and then see if you get the same thing that I get up here on the board. So looking at number 4, 5, and 6, number 4 in particular, the base number, notice it's a negative number, and we'll talk about how that will be important. It is important to note if my base number is positive or negative, and when I simplify this power, then I gotta keep a negative number, just like it shows there. I have to keep that in parentheses. That is important how I punch it in the calculator or when I'm trying to find my answer. So I keep that same base, even though it's negative, negative 9, and then to the power of, well, 3 plus 5 gives me 8. So this would be negative 9 to the 8th power. Now we'll also talk about when you have a negative number to an even power like we have up here. That means I'm going to take this negative 9 and multiply it by itself 8 different times, right? Negative 9 times negative 9. I'll write this one out just to kind of see it. But if I multiply this by itself 8 different times, what's going to happen to my final answer? Is it going to be a positive or a negative number? You can kind of think about it. But if I'm multiplying 8 different negatives together, remember our rule from way back in chapter 2, since there's an even number of negatives here, I'm going to end up getting a positive answer. That's something when we're doing these power problems that you should kind of know. You should know what to expect for your answer. So negative 9 to the 8th power, I know actually is going to be a positive number. So you could also write this. You could write just positive 9 to the 8th. What if I take this problem though? Let's say, and again, this isn't, I know on your notes, I'm kind of making a new problem here. But let's say I change this and I say it's negative 9 to the 7th power. What would that do to my answer? Well, let me write it out. You think about what you think will happen. But I would have negative 9 times itself 7 different times now. And if I multiply negative 9 by itself 7 times, what should I get? A positive or a negative answer? In this case, because it's an odd number of times I'm multiplying the negatives that I have for negatives, I would get a negative answer. So for this, if this was the problem, you would leave your answer like this. Since it's a negative number for the base, and it's to an odd power, I would leave the answer negative 9 to the 7th power. As you're going through problems today on the homework, try to notice that and see if you can spot which problems where you have to leave it as a negative for the base because it's to an odd power, and which ones you can actually, like we did in the blue there, just drop it if it's a negative or to an even power. See if you can figure those out as we go. Good. Going to the next ones. Going through them a little quicker. Number 5, same idea. It's a negative number for the base. I'm just going to keep that negative 4 as my base number, and I'm going to add the 2 exponents. 2 plus negative 5 would give me negative 3. And right now I'm going to leave that answer the way it is. We're going to find out there is a way we can actually deal with this negative exponent. That means something else entirely different that we'll learn sometime soon in one of the next lessons. But right now we can leave that answer as negative 4 to the negative 3rd, and I'm not even going to worry about the even or odd thing for the base because it's a negative number and we'll have to talk about that. So for now, that's good for that answer. And this last one, x to the 7th times x to the negative 2nd times x to the, just remember, if you have 1x just sitting there by itself, it does have a power of 1. So that would be x to the 1st right there. And since these are all the same base, I'm going to add all the exponents together. 7 plus negative 2 plus 1, and I just get x to the 6th when I'm all done. Going to the next slide, here's another rule you learned from the packet yesterday. And again, if you kind of know what's going to happen in these problems, you can go ahead of me, but double check and see that you are getting the same thing and put some of these things in your notes so you have something to look back on in the future. But maybe you saw problems like these yesterday where you have a power, so 3 squared, and then that's to another power, another exponent in this problem. I have 2 different exponents in this problem, 3 squared, and then that 3 squared is to the 4th. If you remember from yesterday how this is written out or what it looks like, what you have in the parentheses goes to the fourth power, so it times itself 4 times. So that means 3 squared is times itself 4 different times. So 3 squared times 3 squared times 3 squared times 3 squared. Then remember that 3 squared just means 3 times 3. So this means I got a lot of 3's multiplied together. Each one of these I got to break apart into 3 times 3 times another 3 times 3 times another 3 times 3 times one more 3 times 3. Well, all that means, using our rules from yesterday too, that there's just 8 3's multiplied together. So this is really the same as 3 to the 8th power. If we were simplifying and writing this as a power, then this would be my final answer. So the packet asked you, well, how can I just jump right from my problem right to the answer? What's the pattern in this kind of problem where you have a power to another power, just like it says? And again, just like the problem looks like. Well, maybe you noticed that all I have to do is multiply these two exponents. I keep the same base number, but I just multiply the exponents together, and that's how it works. So jumping to the next two, without writing in expanded form, I'm just going to do that and jump right to the answers. This is 5 to the 5th squared. Well, that means I'd have 5 to the 5th times another 5 to the 5th. And if I have 2 of those and I write all the 5's, I'd have 10 5's multiplied together. So this is really just like 5 to the 10th power. I can just take these two exponents and multiply them and keep that same base. Same thing if it's a variable. Y squared to the 3rd power would just be y to the 6th. I just multiply those two powers together. So similar to earlier, here's the second rule now we've learned. Again, tried to show you in the packet, tried to guide you to it. Label this, I'd say, as rule number 2. Power to a power. And again, look at the words. It's things that you know. It maybe sounds confusing words, but really it's not. When you have a power, some with an exponent, and it has another power on it, just like this problem is showing with the letters, with the variables. M to the A and then that to the B power. I have 2 powers together. What do? I just multiply them together and I keep that same base. Try these 4 problems below. I'm going to put the answers up here as well, but see if you can go ahead of me and find the answers before I even write them up. So this first one, 3 to the 10th to the 13th power. That'd be a lot of 3's multiplied out together, and it'd be some huge number, but it doesn't say evaluate. It just wants me to simplify. So I don't need to write out some big number for the answer. I just want to write my answer using an exponent. And so the rule tells me, well, if I have 3 to the 10th to the 13th, I just multiply 10 times 13. It's just 3 to the 130th power. Some huge number. 3 times itself 130 times. But I can just write the answer like that. Good. The next one, don't be too fooled. Remember what we said about negative numbers that are our base. It needs a parentheses around it. And the brackets is just another type of parenthesis, correct? Or another type of grouping device. So it's just showing you that it's -2. Since it's a negative, it needs parentheses. And then the brackets are like another parenthesis. It's just trying to show that, oh, this is to the 6th power and then to the 4th. Notice how we have our 2 powers there. I still just multiply those together, and I get -2 to the 24th power. Now, recalling what we did in the last page, can I simplify this anymore? Since it's -2 and it's to the 24th power, which is an even number, yes, I can, right? A negative number times itself an even number of times to an even power will end up being a positive. So if you left your answer like this, especially early in this chapter, I wouldn't count it as wrong. I would like you to understand, though, that really, for this one, since it's an even power, I can just write it as 2 to the 24th, because that will end up being an even number. Good. To the next one, t to the 8th to the 4th power. Again, even with the variable, same thing. I can go right through this one. 8 to the 32nd power. I can multiply 8 times 4. And that last one, we're going to learn next year in intermediate algebra, there's a way to deal when I have something like x plus 2 in the parentheses. But right now, just know, like even something like this can be your base. So that's really our base, x plus 2. Notice that I have 2 exponents. I'm just going to multiply those together. I'm going to keep the x plus 2 as my base. Right now I can't, because there's an addition sign, or even if there's a subtraction sign there, I can't do anything more with that. Again, in the future you'll learn a way to deal with it, but right now I just have to say, oh, this is x plus 2 to the 40th power, and that's as much as we can simplify that one. Then, lastly, you learned a third rule yesterday about applying products or power properties with products, and you learn that some of these problems here that look kind of simple, even where they're just multiplying numbers together in parentheses and it's to a power. A lot of times you might just think, well, if I was actually going to figure out the answer to this problem, I would probably just take 2 times 3, since I know both the numbers, right? And then I would square it. So I would get a final answer of 36, just showing you that, well, that's probably what we do most of the time. But they just want you to see that there's a rule. In case I have variables in a problem like this, or in case, look at the third example, in case I have really big numbers and we don't necessarily care what that really big number is, we just want to simplify this, right? The answer using exponents. Well, there's a way to do that too. And what I do, maybe you figured out from the packet, is when I'm multiplying, okay, again, think of the last slide, I had addition in there, but if you are multiplying things together, and we're going to find for dividing this works too, but for multiplying, if I have things in parentheses like this to a power, I can just take each one to that power separately. So this can be just written 3 squared times 2 squared, and that would be our answer. Now, just showing you that it works and that this does actually equal 36, okay? Taking a second to look at that. Well, 3 squared gives me 9, and 2 squared gives me 4, and yep, 9 times 4 gives me 36. So this does work. It's something we can do in math. But they're just showing you a rule whenever you have things multiplied together and it's to an exponent, I can just take each one to that exponent. Sometimes people like to say the word distribute. It's almost like distributing the power, at least it looks like it. Really the word, what you're doing is applying the power to each thing, but if you want to think of distribute and use the little arrows like we've used in the past, I'm okay with that. Just know really what we're doing is applying that power to each thing. So even this next one would be 4 squared times 3 squared, and that's it. It's not asking you to evaluate, it's just saying simplify, okay, and writing our answers with exponents in it. So that's as good as it gets, so that's all we have to do. Same thing with this last one, 25 times 46 to the 7th. You don't have to find that big number. It's just asking you to use this rule, 25 to the 7th times 46 to the 7th. So our third rule that we learned from the packet yesterday, you can label as number 3. Again, we're going to learn 6 rules total, so really you've learned half of them already just from the first 2 days here of this unit. But third rule is power, when you're using a power on things that are multiplied together. Whatever they are, if they're multiplied together, you can just apply the power to each one separately. Again, try the 4 problems right here, and I'm going to show you the answers right now to them as well. Like this first one, 42 times 73 to the 11th power. Again, if you want to think distribute, if that helps you figure out what to do, that's fine with me. Really know what we're really doing is applying that power to each thing. 42 to the 11th times 73 to the 11th. If I punch this in my calculator, or I punch this in my calculator, they are the same thing. It works. Even if I have variables, this next one, realize we don't usually put the dot in there, correct? But when numbers are next to variables or variables are next to variables, it means multiply. So yes, even here, the same thing happens. I'm going to take both of these variables. Remember, a variable just stands for a number. So it's saying I have 2 different numbers in there. They're times each other, and they're each to the 5th power. So what do you know? Then I just take each one separately to the 5th power. X to the 5th, Y to the 5th. That's how I write that. The next one, we're going to start using power, or some of our rules for powers together. Same thing here. I'm going to take X to the 5th, and I'm going to take Y to the 3rd to the 5th. And think about what we know when we have 2 exponents. Those 2 are going to be multiplied together. So see if you got this one right. I get X to the 5th, because that's just, it didn't have an exponent on it before, so now it's just X to the 5th. But the Y will be to the 15th. I multiply those 2 together like that other rule we learned said. There's what I get, X to the 5th, Y to the 15th. This last one, same thing. In the parentheses here, 3 and Y, really, they're multiplied together, right? It's like I would have a little dot there. If we wrote that in, we just get an algebra where we don't write the dots in typically, but that's what it would be. And it's all to the 3rd power. So both these things separately go to the 3rd power. 3 to the 3rd power, and then Y squared to the 3rd power. I'm going to multiply those exponents together and get Y to the 6th. If you wrote this down, this is pretty good. Last thing I would say about problems like these is powers that you can figure out pretty easily are the ones you should put in the answer. 3 to the 3rd is definitely one I would expect that you guys should know. 3 times 3 times 3 is 27. So really this final answer you could write as 27 Y to the 6th.